Deep beneath the red dust of Gabon, Africa, scientists found scars that shouldn't be there. Veins of uranium that looked used. Not mined. Not melted. Split. The measurements made no sense. Lab technicians ran the tests again. Then again, the numbers didn't change. The uranium ore was missing uranium-235, the isotope that fuels every modern reactor on Earth. Yet the surrounding rock was laced with fission byproducts. Xenon, neodymium, cesium, the unmistakable debris of a nuclear chain reaction. The paradox was immediate and terrifying. Nearly 2 billion years ago, a reactor had run here. No civilization, no machines, no tools capable of refining uranium. But the evidence was undeniable. Something deep within the planet had achieved, sustained, and concluded a self-regulating nuclear reaction, long before humans learned to split an atom. In 1972, one geochemist whispered what others wouldn't dare print. It's as if the planet engineered itself. Accident of geology? Act of intelligence? Or proof that Earth's deepest physics is really a kind of planetary metabolism we've never begun to understand. The story began in 1972, when a routine uranium shipment arrived at a French nuclear enrichment plant. Analysts ran isotopic tests, something they'd done thousands of times before, and froze. The uranium-235 ratio was wrong. It wasn't 0.72%, as every natural sample should be. It was 0.44. Engineers panicked. Someone, somewhere, must have siphoned off the missing material. A loss this size meant enough uranium-235 to fuel a nuclear weapon. Inspectors traced the ore back to its source, the Oklo mine in Gabon, West Africa, and what they found there rewrote the story of the Earth itself. Deep in the rock, they uncovered 16 distinct reactor zones, each perfectly layered, veins of uranium precisely separated by minerals that acted as moderators, slowing neutrons just enough to sustain fission without explosion. Groundwater had once seeped through the seams, rising and falling like a breath, cooling and restarting the reaction in rhythmic cycles. The configuration was perfect, almost impossibly so. Nearly 1.7 billion years ago, when uranium-235 was far more common, these pockets had ignited and shut down in self-regulating intervals, running for several 100,000 years at a steady 100 kilowatts of thermal power. Scientists named it the Oklo phenomenon and argued for months over impossible explanations. Was the ore contaminated? The measurements wrong? A freak alignment of chemistry and chance? But the isotopic signatures weren't random. Their ratios were eerily symmetrical, too neat, too sustained. If nature had done this on its own, it had engineered a nuclear reactor more stable and more efficient than anything humans had ever built. But the real mystery wasn't that it started. It was the impossible physics that kept it running without melting down. Was it simply geology, or something deeper, a planet aware of its own balance? Imagine standing above that mine today, knowing that beneath your feet, Earth once mastered nuclear physics, without us. Scientists at first refused to believe it. A natural nuclear reactor should be impossible. Fission requires precision, too much uranium, and it explodes, too little, and it dies instantly. The balance window is razor thin. Yet Oklo held that balance for hundreds of thousands of years. In modern labs, even a minor temperature shift can send a reactor out of control. But Oklo didn't spiral. It breathed. When uranium heated, groundwater boiled away, slowing the chain reaction. When it cooled, the water returned, restarting the process, like a cosmic lung inhaling and exhaling through deep time. Its pulse rate? Roughly once every 3 hours. A self-regulating rhythm written into stone. Then came the isotopic fingerprints. Xenon gases and neodymium fragments arranged exactly like those found inside today's reactor cores. That pattern proved it wasn't a chaotic spark. It was sustained, controlled fission. Oklo wasn't just a geological curiosity. It was a masterclass in stability. After billions of years, most traces of such a process should have vanished under erosion and tectonic pressure. But Oklo was buried deep, sealed beneath kilometers of rock, as if the planet had archived its own experiment for future eyes to find. That's when the question shifted from how it happened to why it endured. Some saw divine fingerprints. Others spoke of planetary intelligence. And a few asked questions that drifted beyond physics into philosophy. Maybe Earth didn't just host life, it learned from it. Because if a planet can run a nuclear reactor for millennia, regulate it, and leave its blueprints in atomic memory, what does that say about human intelligence, whose greatest nuclear achievements, like Chernobyl and Fukushima, failed in mere decades? The truth blurs the line between geology and consciousness. And that brings us to the most unsettling question of all. Was Oklo less an accident and more a message from deep time? Its water rose and fell like a cosmic lung, inhaling heat and exhaling pressure over hundreds of thousands of years. The Oklo reactors weren't just chemical curiosities. They were living systems in miniature, a heartbeat of the planet itself. Human technology fails in decades. Nature maintained balance for millennia, self-regulating through mechanisms we are only beginning to understand. The rock itself became a ledger of energy, a record of self-correcting physics. Patterns of xenon and neodymium, frozen in stone, mapped out cycles of near-perfect equilibrium. It is as if Earth had experimented, learned, and archived its successes for a distant observer to find. And these weren't errors avoided by chance. Subtle isotopic fingerprints reveal efficiency, precision, and an uncanny resilience that challenges our understanding of physics. Consider the scale. Hundreds of thousands of years of cycles, with heat, water, and uranium orchestrated in near-perfect harmony. Human engineers can barely sustain a reactor for a few decades without catastrophe. Yet here, deep beneath the surface, Earth maintained a nuclear reaction with no meltdown, no disaster, for periods that make human lifespans invisible. And it wasn't just fission. The planet's systems, the flow of groundwater, the shifting rock strata, even the erosion that slowly reshaped the landscape, worked together like a masterful orchestra. Emergent order arose from natural laws, creating something stranger than design. Processes that self-correct, self-regulate, and endure beyond human reckoning. Physics itself seemed to contain wisdom, a memory written in matter. Stand anywhere on this planet, a forest, a city, a desert shore, and consider what might be cycling beneath your feet, silently balancing life and energy on scales we cannot yet measure. What other processes, hidden beneath mountains and oceans, operate beyond observation? What else might Earth be doing that we mistake for coincidence, or the natural baseline, when in reality, it's an intelligence embedded in cycles, patience, and time itself? The questions remain unanswered, and the awe is ours to feel. If a planet can perfect nuclear processes for eons, what else could it be accomplishing silently, waiting for us to notice or to understand? What if the processes beneath our feet are far more interconnected than we imagine? The Oklo reactors show a system in balance, cycles repeating over hundreds of thousands of years without catastrophe. The question isn't whether Earth thinks in any conscious sense, but whether its systems operate with a complexity that challenges our definitions of intelligence. Self-regulating feedbacks, written into the interactions of matter and energy, create emergent order we are only beginning to measure. Consider the rhythms of the planet beyond Oklo. Groundwater aquifers rise and fall, heat flows through the mantle, microbial ecosystems recycle nutrients, and climate oscillations keep cycles of energy and life in delicate equilibrium. The carbon cycle, forests, oceans, and rock weathering, has maintained habitable atmospheric CO2 levels for millions of years. The nitrogen cycle, regulated by bacteria, converts atmospheric nitrogen into bioavailable forms, sustaining life. These are not conscious actions, but they maintain balance with astonishing precision. And we are mere witnesses. Mountains rise and fall, rivers carve canyons, oceans circulate currents with perfect timing, and we barely notice. What appears as coincidence may be the subtle echoes of processes operating silently for millennia. Energy flows, chemical reactions, and feedback loops interact in ways that archive success and correct imbalances over geological time. The rock itself became a ledger of energy, a record of self-regulating physics. It is as if the Earth experimented, learned, and archived its successes for distant observers. The emergent order of these systems hints at intelligence, not conscious, but persistent, adaptive, and awe-inspiring. Stand anywhere on this planet, a forest, a city, a desert shore, and consider what might be cycling beneath you, regulating systems we have barely measured. If Earth has been mastering these processes for eons, what else could it be doing right now that we haven't noticed? Hidden mechanisms may silently maintain the balance of life and energy on scales beyond human comprehension. The planet continues its quiet rhythm, unseen and almost unimaginable. Beneath mountains, through aquifers, across the mantle, energy flows in cycles older than human memory. The Oklo reactors were not an anomaly. They were a glimpse into a system in balance, a demonstration that matter, water, and heat can interact with astonishing precision over hundreds of thousands of years. Consider the carbon cycle, where forests, oceans, and rock weathering stabilize the atmosphere, or the nitrogen cycle, where bacteria transform inert gases into life-giving nutrients. These processes operate without conscious intent, yet the emergent order is undeniable. Human engineering pales in comparison. Chernobyl and Fukushima remind us that even our most advanced designs fail within decades, while Earth has maintained equilibrium across eons. The lesson isn't one of mysticism, it's of scale and humility. The planet does not think in a conscious sense, but its systems function with such complexity, self-correcting through feedback loops, that the outcome appears almost intelligent. It is an orchestra conducted by physics, chemistry, and biology, where each element plays its part in perfect, unseen harmony. And we are spectators, standing anywhere on this planet, forest, city, desert shore. We are above layers of activity we cannot measure, regulators we do not understand, a hidden architecture that sustains life. Every glacier's retreat, every river's seasonal swell, every bloom of plankton is a note in this ongoing symphony. The true wonder is in the subtlety, a cycle completed without catastrophe, a reaction moderated by the natural world itself, isotopic fingerprints written into stone as if to whisper, here is what works, preserved for any observer patient enough to notice. If Earth can maintain such systems over millions of years, what else is silently unfolding beneath our feet? What processes, unseen and immeasurable, continue to maintain the balance of life and energy, quiet, precise, relentless? We cannot fully know, but the awe it inspires, grounded in science and observation, is real. And for now, that is enough.